This is your practice test. Which is the domain? Which is the range? Okay, so domain. Well, I like to write what the relation is first. So 1, 2, 3, 4, 5. Yes, I know those only negatives on them. So -5, 0. -4, -3. 0, 2. 1, -1. And 2, 1, 2, 3, 4. Okay, so I know I like to do it like this. So -5, -4, 0, 1, 2. Okay, -5. So that looks good for this one. That's the only one that looks good. Then this one, it says, fill in the blank. In the relation involving apples, the more apples picked, the heavier the basket gets. So over here, I would have number of apples, and this is pounds. This is how heavy it is. This right here, the number of apples picked, that is my independent variable. Order pairs to be graphed. Okay, so it wants to know what the scale for the x-axis is. So I'm going from 0 is my lowest, 8 is my highest. So scale factors, if I'm looking over here, and I'm going to go along the bottom, and what's my scale factor on this? Here, I'll even draw that for you. What's my scale factor? I would say 2. I would go up by 2. I would not go up by 60 because the highest number is 8. Wouldn't go up by 8 because the highest number is 8. That's what I would pick. And then I'll do red. So the lowest number on this is 30, -30. The highest is 60. I think I would do a scale factor of 10 on that. Last but not least, this starts at 120. Oh no, it does not. We have the lowest value is 60. The highest value is 180. I might go by 60s, or actually I might even go by 12s. I think I would do either one of those. Because if I went up by 12s, I would go over 10. If I went up by 12s, I would go over 10 tick marks. If I went up by 60, I would only have 3 tick marks. So I would go with either one of those. I kind of like the scale by 12, even though 12 doesn't go into 90 evenly. I still might like the scale factor of 12 better. Okay, is not a function. So if I drew a vertical line up, this is not a function. If I drew vertical lines, that passes, so yes, that's one. Vertical lines, yes. Vertical lines, yes. Okay, Jessica wrote the following sentence on her homework paper. Is Jessica's statement true or false? This equation, function notation, no, this is not function notation. This is standard. Standard notation. So this is false just because they use the wrong vocabulary word. Okay, so this is saying I'm going to plug in 6. So f of 6 equals 2 times 6 plus 15. That is 12 plus 15. So f of 6 would come out to be 27. Change my pen. I plugged in this one. So f of x Nope, I didn't mean to write f of x. I meant to write f of negative 1 plus 4 equals. So f of negative 1. Oh, I didn't mean to write the f. I meant to write 3 times negative 1 minus 5, and make sure you put the plus 4 on there. So f of negative 1 plus 4 equals negative 3 minus 5, and we're going to add that 4 on there. So f of negative 1 plus 4 equals negative 8 plus 4, which is negative 4. Okay. Determine which situation is discrete or continuous. At Apple Acres, the more apples you buy, the less expensive the apple is. Well, let's think about it. If we're plucking apples, boys and girls, are we plucking portions of apples? We are not plucking portions of apples, so that means this has to be discrete. Over here, Paola rolls a ball down a hallway. She records the distance and the ball has traveled every 5 seconds. Well, guys, 5 seconds. We don't go from 1 second to 2 seconds. We have space in between. We can have 1.2 seconds, 1.11111111 second. Same for distance. We're talking about distance. You don't just hop. The ball's not going to hop from one distance to the next and like poof for a second and go away. So this one is continuous. Dominic earns $10 per hour making pizzas. He makes the graph of wages for when he works anywhere from 0 to 60 hours. Okay, again, hours, time is always going to be continuous. The amount of money you make is going to be continuous. Now, if it was talking about today you make $4.57 per hour and tomorrow you make $5.35 per hour, if it was talking about those jumps, then it would be discrete. But this is talking about your hours. How many hours? Okay. Mr. Borden was giving a $50 gift card to use at the bowling alley. It cost him $10 per night to bowl. Each time he goes to the bowling alley, he records. Because this is day 1, day 2, day 3. We don't have middle days. So this is discrete. Okay. Write this in standard form. So that means, again, AX plus BY equals C. A, B, and C have to be integers. I always spell integers wrong. A cannot be negative. It can be 0, but it can't be negative. So that means I'm going to get my 5x to the other side. I get negative 5x minus 2y equals negative 6. I'm going to multiply everything by negative 1, and I'm going to get, oops, I forgot to do it on that side. 5x plus 2y equals 6. Okay, is it linear or nonlinear? Well, it's in y equals mx plus b form, so that means this is linear. This one, y equals 4 plus 3xy plus 1. The fact that you have these two multiplied together, this is nonlinear. These are squared. That means nonlinear. Okay, this one, I can combine like terms. So negative 2x plus 25 equals negative 4y. That is linear. Has both an x and a y. They're both in the numerator. They are not in the denominator. They are not multiplied by each other. And they both have exponents of 1. Okay, this graph shows the relationship between the time George walked and the distance he is from school. Analyze the graph. Okay, so let's look at it. So here I'm increasing. Here I stayed the same. So I probably stopped and rested. And here I probably ran home. Or ran to wherever I was going. The graph is nonlinear. Is that true? That part's correct. Let's change this. So nonlinear, so it is nonlinear. So these are my two choices. So that means automatically this goes away because this is neither one, it's not a linear function. It does have parts of lines. It has line segments, but it is not one line. Okay, then it shows that George left school. He walked slowly for a short distance, then stopped for a while, then walked very quickly at a longer distance. The other one says it shows that Georgie left school. He walked very quickly. Quickly would go up faster. So I'm going to say this one right here. It says use the graph to estimate the x and y intercepts of this function. So this right here is the point -1, 0. This is approximately 1, 2, 3, 4, 5, 6. That's approximately that. This is 2, 0 and 3, 0. Okay, -1, 0. Can't be this one, can't be this one. So it's one of these two. So -1, 0, 0, 6. We've got this, we've got this. 2, 0, got that. 3, 0, got that. There we go. It did help that there are 4 points, and this one has 4 points. Okay, diving. Lisa dives into the pool from the diving board. Then she swims back to the surface. Her depth over the time is represented in the function shown in the graph. So let's talk about it. Here's when she leaves the diving board. Here's where she hits the water. Here's where she stops going, I don't know, lower. She probably doesn't hit the bottom of the pool. And then we're back up to the water. Okay, the function representing Lisa's dive is negative, where x is between what and what. So this part right here, when she's in the water, the lowest x value is 1. The highest x value is 2, 3, 4, 5. So it's between 1 and 5. Okay. So the function, is this linear or nonlinear? It is nonlinear. The graph is symmetric when what? Right here would be my line of symmetry. So that's when x equals 1. If f of x has a relative maximum when x is equal to 8, then the function f of x is increasing as x increases towards 8, and then decreasing. True. So what it's saying is if 8 is here, this part right here is increasing. By the way, that's the y value. So as x is getting bigger, y is getting bigger. And then it's decreasing as x increases from 8. So it's doing that. So this is a relative maximum. Okay, the end behavior. Okay, so this is a positive slope. We're just going to go like that. So as x gets bigger, x is getting bigger, y is also getting bigger. This says, though, y is decreases as x Okay? It says x increases, y decreases. That's not true. This would be a negative slope. Okay. Use the graph to find the extrema. So this right here would be negative 2, negative 2.2-ish maybe, and 8. This B is, it looks like negative 1, negative 7. Okay, fill in the blank using the available choices. So from when x is less than 0, this part right here, that graph is increasing. Remember, if you have a hard time with that arrow, don't look at the arrow. Just look at what's happening. As the x's get bigger, the y's are getting bigger. I love how I left off the ER on that. Okay, so now we're going to look at the middle space. We're talking this right here. Okay, no arrows happening right there. Okay, so as x is bigger, y is smaller. So that means we're decreasing. Good morning, Sadie. Okay, and last but certainly not least, we're talking about this portion right here. Okay. And if you need to, ignore that. As x is getting bigger, y is getting bigger, so we are increasing. Okay. Use the graph. Okay. The relative minimum is about 0.7. Oh, sorry. These are two different graphs. So here's my relative minimum. That's at negative 1. Why did I put 0? Negative 12. Then up here I have 1, 4. Here I have 3, negative 12. Okay, so f of x, that's this one up here, has blank x-intercepts. Well, how many? Oh, I didn't do the x-intercepts. Oops. X-intercept, this is, I don't know, 0.2, comma 0, 1.8, comma 0, 3.8, comma 0. How many x-intercepts does it have? Has 3 x-intercepts. Oh, it helps if I read what it says. Has blank intercepts than g of x. Has, okay, so if I look at the intercepts here, guys, they like to write it. I do not like that they don't write it as points. Okay, so they have the same amount of x-intercepts. They has, oh, I forgot. I didn't see that one. Has more x-intercepts. Has greater relative maximum value. Which one has a greater relative maximum? This is the relative maximum. Oh, you know what? Let's change colors. Just because This has this relative maximum. This is this relative maximum. So, which one has a greater value? G of x. The function is linear. False. The function has 3 zeros. It actually only has 2 zeros. False. Negative 6 is a solution of the equation. Well, this is negative 1, 2, 3, 4, 5. So negative 6, 0 is a solution. So this is true. 6 is a solution of the... No, there's nothing over here. So that's not true. Negative 1 is a solution of the... No. Oh, yes. Sorry. Negative 1, 0. Yes, true. And the function has 2 solutions. True. Okay.